Okay, so I see in the classroom, I think Emily, Allison, and then is that Eliza? Okay. All right. My mask face recognition skills are being put to the test here. Okay. Oh, and now I'll have to like use my psychic powers because the camera is no longer on, but that's fine. So Allison and Eliza or Eliza, if you want to say something, I guess just have Emily like.
I think they're gonna log in on their computer.
You're gonna log in too. Sure.
Okay.
Sounds good. That works too. Great. Yeah, so I guess it may be helpful to just have one of you have your speakers on so that everyone can hear, and then everyone else could mute themselves so that we don't get crazy feedback.
Yeah, we'll do that.
Lovely. Sorry. Okay. I heard the we can part, but not the rest of what you were saying.
We can do that. Yeah.
You can do that.
Yeah.
Okay. I did.
Sorry, yeah.
Lovely. That sounds great. Okay. So, well, welcome back, everyone. Hope you had a nice weekend. I thought we could start by giving you all some time to ask any questions you might have about the third assignment. A few of you reached out to say you had questions. So we could, start there. Well, why don't we start there before I tell you what else we're going to talk about. Does anyone have any questions on the third assignment that you'd like to bring up? Emily.
Yeah, I had a question about the for loop part you were talking about for the assignment. Like how that works, and I guess in general, like how that works, and then calling the other function inside the loop, and where I believe I have to convert whatever is in the loop into a string because it was a number. So how and where that would happen, is that inside of the function that I'm creating, or is that outside of the function? I don't know if that makes sense.
Got it. Yes. Okay. So would you like to share your screen, or would you like me to share my screen? What do you think would be?
Maybe you share your, maybe if you could share your screen. Would it be possible for you to share your screen?
It would be possible, yes. Let me do that. Okay. Okay. Let's see. So open this up. Okay. So you are doing the for loop version here, or
yeah, that version. Mm-hmm.
Okay. So one place to start is we could, yeah, so well, okay, so let's go through the pseudocode first, and then we could kind of dig into the implementation if people would like. So we're going to just, conceptually, we're going to start by setting this variable y. So that's going to be what we return in the end to the empty string. And then we're going to have this variable incremented to see whether we've incremented the number yet or not. We'll start it off as false. Then we're going to loop through each character in B. So B is going to be a binary string. Mm-hmm. And so that's going to be 00101, or sorry, I guess the animation is moving faster than I can speak out the numbers, but this orange thing on the bottom, the dark orange part is like the base 10 number, and then the light orange piece is the corresponding base 2 number.
Mhm.
And then the places here, so this is like, in base 10, the way that the digits work is we've got 10 to the 0 is the first decimal place, then 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, etc. as you go from right to left. In base 2, it's the same thing, but we have 2 to the 0 is the first place, 2 to the 1 is the second place, 2 to the 2 is the third place, etc. Okay, so that's what this kind of graphic is showing. Okay, so, and Kareem asked, do we write out our own string for B? Not quite yet, but that's a good question. Well, yeah, we'll get there. So, yeah, so the kind of meat of the suggested implementation is to write this increment function that takes in a binary string, and then increments it by 1.
Yeah, I think I was able to like get the function, but then I'm not sure with I think Kareem's question was also sort of what I was wondering about. Like, do we need to write a string before, convert it to a string? Is that part of the while or the for loop? Yeah.
So, one thing, so if you have the increment function working, one thing you can do is say, how could you get from an answer to whatever the user types in? So let's say the user types in, n is 10.
Mm-hmm.
Then we could say, start out our string as 0, because we know that answer. And then we could say, let's increment it, n times. And then after we're done incrementing that string, then we could return the string.
So you would call increment before you define the increment function, or you define the function and then you call it at the end?
I don't actually think it matters, but you can put this up above.
So
Yeah,
getting an error before, yeah.
Okay, we could test whether, sorry, this is ignore the title here, but we could say, increment, it just prints out whatever the string is.
Mm-hmm.
So let's see. This is not an answer, it'll just print out 0 some number of times, but B equals increment B. Right, so you could just return B. Okay, there we go. And then if, we pass in 0, it'll just return the original thing. Let's see if it crashes if we define increment below, after we call it.
Mm-hmm.
We can test that. Oops.
Go back to the.
No, it works. Yeah, it's okay.
Okay, it must be something else I have a problem with then.
Was the increment function itself clear, or how are people feeling about that? You can ask questions, yeah. Oh, Fawn-Marie, yes.
I would love some clarification, because I watched the video of the Friday class. We haven't talked about the increment, and I look at the instruction. I'm not so clear, what's a function?
What a function is?
Oh, I mean, like, what is
Okay.
increment?
Oh, increment is just something that, like, what does increment mean? So increment is just you take a number and you incrementing gets you the next number. Like if you increment 1, then you get 2. And if you increment 2, you get 3, etc. But then in binary, if you increment 0, then you get 1. If you increment 1, you get 1, 0, then 1, 1, 1, 0, 0, 1, 0, 1, etc. So, and then, you know, if you were to, the reason you have to represent these things as strings is like, you know, Python by default works in base 10. So 0 is going to, you know, so for example, 1, 0 in binary is going to be the value like 2, but in base 10, it's the value 10. So we have to know what we're talking about because, you know, Python's not going to read your mind. And so the way we're representing this stuff is with strings for each of these numbers. And we'll know ourselves that, you know, the strings we get out are going to be the binary representations of the base 10 numbers that we pass in. This line won't run, by the way, so we can just comment it. Does that make sense? So just to like make it super concrete, the increment function, if you pass in the string 0, it should return the string 1. If you pass in the string 1, it should return the string 1, 0, etc. And then the way that that function works, oh, sorry, is, well, this kind of walks you through the algorithm for how you create that function, or one way to create that function. So you start with an empty string, you set this variable to false. Then you loop through the characters in reverse order. That might be a tricky thing. So if our string is like 1, 2, 3, 4, 5, which is not a valid binary string, so we'll never get that. Anyone know how we could get this string in reverse order? Like if I wanted to print out each of the characters in this string in the reverse order, how could I do that?
Can you hear me? Can you hear us?
Oh, yes, now I can.
Okay, go ahead, Elisa.
Oh, there you are. Okay, I'm like, yeah, okay, you added a window. Yes, now I see you.
So you put the square brackets and then the two dots, and then -1.
Yeah, great. Yeah, so here's what this, you know, these lines do if I don't do what Lisa just said. So it just prints out the characters 1, 2, 3, 4, 5 in order. But I can reverse the string by using this, you know, slice notation. So this is shorthand for start as soon as you can, go as late as you can, and then increment by -1. So starting as soon as you can, if the increments are -1, starts you at the end. Ending as late as you can, if the increments are -1, means going all the way to the beginning. And then counting back by -1 means we're going back one at a time. So we're dealing with 5, then 4, then 3, then 2, then 1. So it gets us the characters kind of right to left instead of by the default, which would be left to right. Allison. Oh, you have to unmute. Or
Sorry.
someone has to unmute.
Yeah, it was me. I'm just still figuring out how to use this. My question was, I just generally don't understand how to convert to binary. And I was wondering, without the code, if you could just give us some numbers and explain how you would do it.
Yeah, sure.
But if you don't understand what's actually going on.
Yeah, so the way that I'm suggesting as like the beginner approach is you just start with 0. So 0 is also 0 in binary. And then if you want to get to the number 10, you just increment that, the like binary representation 10 times. So like, and then you just have to know how to count in binary. So the way it works is you take the rightmost thing, and if it's a 0, you change it to a 1. If it's a 1, then you add another digit, that's a 1, and then you put a 0 on the end.
So, okay, I'm kind of saying this as like someone who, assume I'm a dummy and know nothing. Let's say I gave you the number 15, how would you translate that to binary?
Yeah, so let's count up. So 0, that gets a 0. 1 is a 1. 1, 0, that's now a 2. So we could put in parentheses the base 10 representation. And then 101, 110, 111.
Is there any like pattern to this? Like, I feel like this is like a foreign language or something, so I'm trying to figure out how.
Yeah, so think about how you count in base 10. So we go, 1, well, maybe I won't draw out those arrows anymore. 1, 2, 3, 4, 5, 6, etc., all the way up to 9. Now we've run out of room here because base 10, we can only, or sorry, I forgot the 0 here. This is the highest digit we've got.
Okay.
So now the way we increment the number 9 in base 10 is we add a new place, which is going to be now the 10's place, and then we append zeros, in all the other positions.
Okay.
So it gets, so now we have 1, 10 and 0 1s. And then we increment those all the way up to 19. Now we have to increment this piece. Now we can't increment the 1's place anymore. So we increment the thing that's next over from the right. So we get to 2, and then we append all zeros. And then, when we get to 99, now everything's incremented. So we increment this one, the 1's place, which means we want to increment the 10's place and then replace with all zeros. So it would be like 9 plus 1 and then a 0. But then the 10's place is already full. And so we have to now add like 10 to the second, which is 100. So we add a 1 and then all zeros. Does that make sense? Oh, and Fan Marie has a video that she's linked to in the chat.
Oh, thank you. I'll check that out. Okay, so
Oops.
how do you then
And
go
then
from that to binary?
Well, did this pattern make sense? So it's like, you go from, you have 0, and now that's not, so the maximum digit we can get in binary is a 1. So we start with 0. Now we can increment the rightmost thing. So 0 turns into a 1. Now, when we want to increment that, we can't increment a 1 because 1's the biggest number we can, biggest digit we can have. And so we add a place to the left and then add all zeros to the right of that leftmost digit. So 1, 0. And then to get, to increment this, if the rightmost thing is a 0, we can increment it. And so we do. Now we get to 1, 1. And now to increment this, well, we can't increment 1 because we're already at the maximum. So this would be, so the incrementing would be 1 plus 1 followed by a 0. But we can't increment a 1. And so to increment a 1, we have to change this to a 1, 0. And then we put the whole thing together. Does that make sense?
I guess why is it not going from, it seems like maybe I'm just still not understanding that. It seems a little inconsistent. Why would it go from, why is it not going, so I understand like you can't increment past 1, but why is it not going from 11 to 110?
So if you think about what do these places mean? So the first, so by first I mean rightmost decimal place is going to be 2 to the 0.
Mhm.
And then after that, we're going to have 2 to the 1, 2 to the 2, 2 to the 3, oops, etc. And then we can write out what's the like base 10 representation of each of these things. So 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2. Does anyone know what that? Oh, sorry. Okay. Sorry. That was silly. I typed it as I was asking. Okay, so it doubles each time, right? So if you think about like, how do you read out something in base 10? So let's say the number 123. Well, we could look at the base 10 digits, and that's going to be, 10 to the 0 is the rightmost digit. 10 to the 1 is the 1 from the right. Then we have 10 to the 2, etc. So 1, 2, 3 means 1 times 10 to the 2 plus 2 times 10 to the 1 plus 3 times 10 to the 0. So if we simplify that, we get 1 times 100 plus 2 times 10 plus 3 times 1. And then we can simplify that. 100 plus 20 plus 3, which is 123.
I guess.
So with,
Oh, God, sorry.
and then with binary, so if you want to read out, okay, what does 100 mean? We could say, okay, well, what's this, this place? Well, we could look here. So it's, 2 to the second. So it's 1 times 2 to the second plus 0 times 2 to the 1 plus 0 times 2 to the 0, which is going to be 1 times 4 plus 0 times 2 plus 0 times 1. And that's 4 plus 0 plus 0 is 4.
Wait, but you up there said 4 is 101.
Nope, 4 is 100. Or 100, sorry, it's not 100. It means this is yeah. So for each of these, it's the binary representation, and then in parentheses the base 10 representation. So 0 is also 0 in binary. 1 is also 1 in binary. 10 is 2 in binary. 11 is 3 in binary. 100 is 4 in binary, etc.
Can you get rid of the arrows? The arrows are kind of confusing.
Well, they're intended to indicate incrementing. I'm going to delete this anyway. You can go back in the notebook and in the video and then see. Yeah.
I guess what I mean is like, because I thought you were saying, I thought it was, at least to me, it was more clear when you just did different, like made everything like a new line. Because to me, like I thought the 4 was referring to 101. I didn't realize what they like. If you could just increment it, like just have every, I guess, number be its own line instead of having the arrows.
Are you still confused, or is
I was
it?
gonna take a screenshot of it.
Sure. The other place you can look is in the assignment. There's this animation to kind of walk you through it.
Okay.
So I would, you want to make sure, or you could, go through that animation and really kind of make sure you're understanding how is this working, and where are these values coming from.
Okay, all right, I can just write, if you go back, I'll just write it down, it's fine. Thanks.
I mean, I can paste this into the chat if you want.
Sure, thank you.
Sure. Okay. Any other questions on, so I should say there's, this is the approach that I found, I thought would work best if you're kind of new to thinking about binary, because, that'll get you to understand how does counting in binary work. There are other ways to, you want to try the modulo approach. Sure.
No, I didn't mean now, just in general. Can we do that?
Oh, yes. Yep. You can. Yeah. Yes. Yeah. You can use any approach you want. You can write, you even can pick a different approach beyond what, anything I've recommended here. So, yeah. Yeah, so I suggested 2 alternative ways of getting at that, of converting to binary. So the version 1 is like, it's kind of like if you were to just solve out algebraically what goes in each place, this is how you do that. So this is like the, sorry, Allison, yes. It's a little hard to see the hand raisings when I'm like screen sharing and trying to keep track of multiple people in one way. So just, unmute yourself and speak out, and then I'll, then I'll notice.
I had another question, but I don't want to interrupt what you're saying. So if you want to finish what you're saying, I can ask that, because it's related to the binary converter, but not directly related to what you're talking about right now.
Got it. So the suggested experienced approach 1 is how do you kind of mathematically solve out in the most efficient way what goes in each decimal, when you convert one base to another base. And then the experienced version 2 is kind of the classic way that you might learn in an intro to computer science class how to convert to binary. And it uses floor division. Did you have a question though, Allison? Oh, you're muted.
Sorry, I'm just getting used to the mouse. My other question was, why are we converting this to a string? Is the input supposed to be a string and then you keep it as a string, or are you inputting as a number and then converting to a string?
So you're going to get in a number, like an integer,
Okay.
and you're going to get out a string. Because, so think about how would Python represent, this number? We want it to mean 4, but it actually means 100 to Python. Because Python works in base 10. So the way that we're going to distinguish that in this assignment is to use the character string 100. And then we know, if we're converting, if we pass in 4 and we get back 100, then, we know how to handle that.
So do you have, as part of the assignment, you have to convert to a string? You can't just keep it as a integer the whole time?
Yeah, I mean, it's not going to work to keep it as an integer because Python won't know that that's a binary representation of anything. It'll just treat it as base 10 if you keep the thing as a string. The way you test your code is, there are these test cases set up. So if you run this cell, it'll tell you whether your code is working correctly for these examples. So if you pass in the integer 0, you should get back the string 0. If you pass in the integer 1, you should get back the string 1. If you pass in the integer 2, you should get back the string 1, 0. If you pass in the integer 100, you should get 1, 1, 0, 0, 1, 0, 0, etc.
Thanks.
And then, you want to think about like, and then, other things to think about are like, do you want to be able to handle floating point numbers? So, numbers with decimals. So if you pass in 10.00, that's the same thing as 10, but, it's not an integer. So you may want to make sure that works. There's another strange thing that happens. So what does everyone think this is if I were to run this cell? 3.14 minus 0.14. What is that? If this were a math class, what would it be?
3.
Yeah. But, oh, actually this works. Yeah, so, sorry. How about this?
I'd expect 0.
Yeah. But it gives you something that's like very close to 0, but not exactly 0. It's because of how Python represents numbers internally. It's actually using binary representations, which imperfectly match sometimes in these weird edge cases with base 10 representations. I mean, in practice, 10 to the minus 17th is pretty close to 0. So, we don't notice that typically, but it's just a weird edge case. So if you were to ask, like, does this equal 0? Then it doesn't. But like mathematically it should, but in Python it doesn't. So one edge case to potentially check for, if you want to be fancy, is you don't necessarily care that your number has exactly 0 in the decimal piece, but maybe you want it to be like sufficiently close to 0. Something to think about. So you could say, like, if it's in within 10 to the minus 15th of 0, the decimal part, then we'll just call it an integer. Other things to think about are like, what if you pass in like negative 100? That should fail with these algorithms. And so you want to make sure it actually does. So sometimes checking your code is making sure it gives you the right answer when you pass in the expected information. Sometimes checking your code means making sure it crashes when it should. And that it crashes in the right way. Yeah, so if you try to convert like 5.67 to binary in this way, then that should crash it too. And then, if any of you are, looking for, the 3s in the chat, I'm assuming I'm just slow on the uptake there. Yes, that was the correct answer. Good job.
Wait, can we ask
Alex?
a question?
Yes, yep.
Go ahead,
Sure.
Lisa.
So does it mean that Python, before computing any operation, converts the number into binary and then performs the operation and then converts back into base 10?
Well, I mean, it's not Python that's doing that. It's actually the machine compiler. The kind of architecture of what goes on your CPU is kind of beyond the scope of this class. But to answer your question, since you asked it, Python converts the code you type into what's called machine code. Well, sometimes it also converts it to C and then machine code. C is another language. Machine code is like instructions that your computer processor understands. So when you talk about like Intel or M1 or AMD processors, what that means is it's like a little calculator that sits in the heart of your computer and it can do certain instructions. Like a scientific calculator might be able to do like, addition, subtraction, multiplication, take the logs of things, take the powers of things, trigonometric functions. Your computer processor has a similar set of instructions. And one of the things it can do is like take two things and store them in different buffers and like combine them, or add one to things and stuff like that. That all operates on like at the level of like binary representations and very basic instructions. And so a lot is happening behind the scenes when you write a seemingly simple statement in Python to get it to actually run on your like calculator-like CPU. And some of that process introduces imprecision. There are ways around it, like there are fancy math libraries if you need like super high precision, like if you're trying to compute the weight of a subatomic particle or something like that, like you need tiny numbers. There are libraries for doing that, but we won't, or at least I don't think we'll use them in this course unless people want to get into that stuff. All right. These are good questions. Anything else? The last thing I was going to say is if you, if you're good with this and you're looking for like slightly incremented challenge, you can also try extending your convert function to like convert to base 2 by default. But then if someone passes in an additional optional argument, you could convert to like an arbitrary base. So that's a potentially fun exercise if you are so inclined, but that's optional. Like you won't get any credit for it, but it could just be a fun exercise if you are interested in it. All right. Any other questions? Okay. Okay, cool. So let me stop screen sharing for a moment there. Okay. So for the rest of this week, our focus is going to be on like introducing you to Python's data science tools and also finishing up assignment 3 if you haven't already done that. So you can think of assignment 3 like, it's kind of the conclusion of the module 3 material. So now at this point, you have everything you need to, finish that assignment, but you have a few more days if you want them. And then module 4 is going to introduce the data science parts of Python. So most of the content from this week is going to be from module 4. And then to give you like a little sneak peek, next week, we're going to move on to our first Python-based data story for assignment 4. And that will most likely be due 2 weeks from today. And we'll kind of follow a similar format next week to what we did with assignments 1 and 2, where we'll kind of do a brainstorm workshopping session on Monday. But then because assignment 4 is going to be our first like real data science assignment, we're going to take some additional time for the rest of that week to kind of debug your code as a class and that sort of thing. And then the following Monday, we'll give each other feedback in class. And that might also leak into Wednesday, depending on the timing. But the plan for the rest of today is I've put together some slides that I want to use to introduce you to the Python data science toolkit overall, and then also to one of the core packages in that toolkit called NumPy. Is assignment 4 due on Monday, February 14th? It is. That's a good question. That seems right. It'll, I mean, technically be due at like midnight the night before, but so you can still do your Valentine's Day celebrations on that Monday. Yes, Allison.
So it's really due, okay, so there is actually more of a hard deadline this time that you want it by midnight?
No, it's the same as all assignments for this class. You know, the deadline is, you know, it keeps you on schedule. So if you follow the deadlines, you won't be, you know, cramming lots of stuff in at the end of the course. But, you know, you can still get credit for an assignment if you don't hand it in exactly at midnight. If you, yeah, if you want to hand in an assignment, you know, that assignment sometime on Monday, you can. But we're not going to necessarily discuss it. We're not going to necessarily discuss an assignment in class if it's handed in, you know, moments before class. But just like with assignments 1 and 2, you know, we'll do our best with it.
Okay.
But yeah, so think of it, it's not really a deadline. It's like, what do I think gives us the best opportunity for like discussing your assignment and for you to spread out the work throughout the term. But, you know, it's kind of on you to decide if you want to stick to that recommended schedule and what feedback you want to receive. Okay. All right, that's kind of more like the adult version of a deadline. Is it a deadline? Is it not a deadline? We don't know. Yeah. Okay. So let me pull up some slides. Okay. So we're not going to have time to get through all of these, so I'll, you know, pick things up on Wednesday, you know, as needed. But okay, so let's talk about Python modules. So first of all, does anyone know what a Python module is, or has anyone used a Python module? Yeah, Emily. Oh,
I just think
you're
maybe
just
I've
raising your hand because you
used it
knew.
before, I raised my hand.
You
If
raised
it's
your
like
hand. Does
NumPy,
yeah.
like you were talking about, I used that before.
Got it. Okay.
I don't know what it is exactly.
Sure. Does anyone want to like try kind of describe? I mean, it's kind of on the screen already, but Alex, did you want to?
Yeah, for CS1, they give us the fantastic CS1 lib, which has a really great set of tools that you can use to create like separate windows that create graphics and make it so that instead of having to deal with all of the creation of that window, you just have to deal with the little code that does the thing that gives you what you're supposed to see popping out.
Yeah, cool. So that's a great example of like how modules can be super useful. So like, you know, Python comes built in with a certain set of functions. And it, you know, a module can, it kind of means someone else wrote code, or, you know, it could be you, could be the someone else, like you in your past or something like that. But, you know, you have additional code that you can draw on to extend Python's like kind of core functionality. And just like other words that means the same thing as a module, and I am somewhat sloppy in my usage, so I'll just mention them all in case I am not consistent. Library, package, toolkit, toolbox, those all mean the same thing as module. Okay. There are kind of two broad classes of modules that you can use. One class of modules, or one type of modules, are kind of built in. So they come with your Python installation by default, but they're just not like loaded into the workspace when you start your Python interpreter. There is if you're ever curious, there is a list of those modules at the link I posted to it in the notes, which I forgot to share the link to the notes with you. Okay, yeah, if anyone wants to follow along without kind of rewriting what I'm typing on the slides, you can download the slides here. Yeah, so there are lots of interesting libraries like regular expressions. Oh, yeah, it's highlighted because that's the one I use a lot. You could read different things. You could deal with dates and times. Another clear favorite of mine. Formatting text, copying different objects, math, etc. There are lots of them, lots and lots of them. Really, these libraries cover quite a broad range of functionality. But they don't cover every possible thing you might want to do. So the second way to get modules is to install them. And there are literally hundreds of thousands of modules that are just floating around the internet. Some are good, some are terrible. Some are responsible for keeping the internet going. Some are responsible for breaking the internet by spreading viruses to other people's computers. So there's quite a wide variety. The kind of place you can, Googling a package is the best way to find it. But if you know the package name, there's this kind of repository called the Python package index that kind of is the official repository of all Python toolboxes. So you can see there are, as of January 31st, 2022, 353,644 Python packages that you can install. That's quite a lot. Okay. Yeah, and how do you get at them? So if there's the terminal-based way if you're installing something on your local computer, and then there's the notebook-based way, and they are pretty similar. The command is pip for something Python. Let's see, what does pip even stand for? Must be something related to package index Python or something like that. Pip is the command, then install. Usually I put the user flag, -- user, that just keeps it local to your user, so you don't mess up your whole system, for example, for other people using your computer. And then the package name. If you want to install a package in a notebook, you do the exact same thing, but usually you don't have to use the user flag, particularly if it's a collaboratory notebook, because you're the only user of that kind of virtual machine. And then you just say pip install time, or whatever the package name is, but you have to include this exclamation point. So let's just do an example. There we go. So I'll just install that library. Deals with dependencies, what other libraries are needed to use that package, etc. Okay. It's also often useful to get a list of the packages that you currently have access to. And you can do that using the pip freeze command, which is just, if you're in a notebook, exclamation point, then pip space freeze. If you are in a terminal, you just don't put the exclamation point. So let's get a list of all the libraries that are installed in Collaboratory plus the HyperTools package we just installed. There are quite a few of them. Yeah. So here's everything you've got access to beyond the standard Python library, just when you open up Collaboratory. Lots of good stuff there. In order to actually use a module, you use import statements. And there are a few ways of kind of forming these statements. One is to just write import space and then the name of the library. Let's do that. You know what, I'll factory reset my runtime here. Okay. So oops. Let's see if this works. Yeah. So the dir command kind of lists the stuff you currently have access to. It's like what Python knows about. One of the things it knows about is like built-in. Built-in has like all the stuff that gets Python going, like how do you add things? How do you take the absolute value of something, etc. How do you like print something to the screen? So this is like the whole Python language. Then when you import a library, it adds that library to your namespace. And now you can access it. And now itertools, which I couldn't access before, it knows is a module. Okay. You can also import a list of modules in the same line by just separating the modules with commas and then a space. So OS is like a module for dealing with files and operating system level, functionality. And then system is a library for running system commands. We could import both libraries. So, neither library is loaded by default, but we can import both of them. And now we have access to, all the functionality of these libraries. Okay. A third way to import a module is you can call import, then the library name, but then you can rename it to something else to make it more convenient to refer to. So we could, import NumPy just regularly. And now if I want to do something in NumPy, I have to type out the whole library name NumPy and then make, let's say I want to make an array or something. Okay, so that's fine, but it's kind of annoying. But I could rename NumPy to something more convenient. And now I get to call NumPy whenever I want to refer to NumPy, I can call it that more convenient thing. Of course, if I overwrite it, then now I lose that functionality. Like this will break. Yeah. Okay. A fourth thing you can do is rather than importing the whole library, you can just import a specific submodule or subset of functions from that library. So if we just want the log function, which by default is not defined, but we could use the Python math library to import the log function. And now we have access to this new thing. We don't have to care that it came from the math library. We can just use it directly as if it were a built-in function from that point on. You can also do a combination of like importing a specific subset of functions and renaming it. This is kind of a confusing one. Glob is a library for like dealing with other like, it's like a set of convenience functions for dealing with like file system stuff. Inside glob, there is a function that is also called glob, which is confusing. So like, you know, I could list, oh, that's silly. Let's see, do I still have, yeah. Okay, so this command gets the current working directory. Glob lists all the contents of that directory. But I could instead call the glob function like list directory, which is kind of more convenient. I don't know, helps me keep track of like, what's the library and what's the function name? Sometimes those are confusing. Okay, any questions on those? Cool. One thing that I think you learn in CS1 that you should absolutely never do after CS1 or in the real world is like from whatever your library is, import star. So that is a like bad Python hack for importing all of the functions and submodules within a library. But it is super dangerous to do that in practice because like, you know, I could rewrite the, are these set of slides unloaded yet? What does that mean? You mean, are they posted? They are. So it right above your message, there's a link to the slides in the Zoom chat. No problem. Okay. So you know, I could write a library that like overwrites the sum function in Python to like delete all the files in your hard drive, and then call that function sum, S-U-M, which is a built-in function that gets called when I do something like 1 + 1. Okay. Now, if my overwritten sum function, I mean, I could do this now. I'll have to factory reset the runtime. I'm not going to actually have it delete all my files, but yeah, this will be confusing. So yeah, now I want to do what? Oh. Ah, cool. That's nice. There's some kind of safety built in there. Well, it doesn't always work like that. Oh, I just totally, no, yeah. Okay, and now let's see what happens. Nope. Yeah, interesting. Okay, well, anyways, that wasn't as bad as I expected. Let's say the print function, you know, let's see if this works. Okay, so now if I say print hello, yeah. So now I'm like, I think I should be printing out the string but I've rewritten that to be a function that just adds 1 + 1, no matter what it is. But adding 1 and 1 is a like relatively harmless thing. Deleting all the files in your hard drive, uploading all your passwords to like some central repository, those things would be less pleasant. So you don't want to use the import star commands. You're kind of giving someone the trust of your entire computer system when you do that. Okay. All right. In this course, you're probably not going to write or publish your own packages. But if you are curious about how a package is made, like if you've heard the expression like how the sausage is made, how the Python packages are made is actually kind of interesting. And if you are curious about that, my lab has a tutorial for putting packages together, and there's a link to that tutorial in the slides if you want to check it out. These modules and installable libraries are what makes Python so powerful. Like there are a lot of really great languages out there, and one language is, for the most part, as good as any other language. Provided it's like a Turing complete language, et cetera. So in other words, you can like express all the things. In fact, you can like write parsers to convert from one language to another language. So they're all kind of equivalent in that sense. What makes Python special is that is those modules that you can import. And there's like a fantastic data science community and medical community and psychology community, neuroscience community, et cetera, math community. Many academic and research-oriented communities and science-oriented communities use Python. And they, it just makes this wonderful ecosystem of like shareable libraries that are really awesome. To give you like a very, very broad overview, amongst other things, some of the libraries are for like what's called data wrangling. So like getting the data in the format that you want when it doesn't start that way. You can carry out like various analyses, apply like machine learning models to your data to find interesting patterns. You can like fit all kinds of interesting models to your data. Many are already implemented in packages, creating really neat, nice looking data visualizations. And like really almost anything else that you can imagine that involves a computer, there's a good chance that a Python library has been written to do that thing. And maybe I'll end by kind of giving this illustration, which kind of shows how the Python data science kind of libraries are organized conceptually. So you can think of these kind of expanding layers of functionality where you've got Python in the innermost layer, and that's like the core language. And then on top of Python are these other libraries that include NumPy, which we'll learn about next class, Jupyter, that's what Collaboratory is based on. SciPy is called scientific Python. Cython is like a C, has some C wrappers for getting things to run really fast. Those kind of interact with Python directly. On top of those are like data formatting libraries like Pandas, which we'll learn about. Matplotlib is like a data visualization library, et cetera. And then on top of those, you've got fancier libraries that are kind of more high level. And then on top of, so they deal with things like applying like high level machine learning models or visualizing data in like complicated ways or doing like brain analyses. And then on top of those, you've got even higher level libraries like doing really complicated brain analyses and other interesting stuff. So you can also see how like each library is kind of like this tool that other libraries can then use once it's added to this central repository to make new tools. And so you get this kind of exponential growth in the Python community that just adds all kinds of neat, it opens up all kinds of neat options. Okay. All right, so I'm gonna end there for today. On Wednesday, we'll, I can give more time to answer any questions on assignment 3, and then we'll dig more into the into NumPy specifically. Yes, Emily.
Can I, like, because I messaged you if I could ask you a question at the end of class, is it okay if I, like, after class ends, I show you my code?
Yes, that'd be fine. All right, so I guess, would you be open to other people staying during that time, or?
Yeah, that's fine. Oh, sorry.
Okay, so if others would like to stay, is it about assignment 3?
Yeah.
To
Mhm.
ask more about it, to talk more about assignment 3, I'm happy to stay a few minutes, and otherwise I will see you all on